Okay, so now I'm going to teach you trigonometry, a very interesting topic, but just make sure to pay maximum attention in case if it happens that some of the information doesn't sync. Just make sure that you repeat this lesson over and over and over and over again, because trust me, once you can fully understand just this lesson for today, I'm telling you, you will never go wrong as we continue, because everything builds up from this very same lesson that I'm going to start you with and now. So most importantly, I'm going to start with a quick revision so that you've got an idea of where this topic comes from. But in short, it builds up from Pythagoras, what you already know. I'll just first remind you of that, and then from there I will explain what exactly trigonometry is. So if you remember, regarding theorem of Pythagoras, we said we focus on a triangle. Most importantly, not just a triangle, but a special type of a triangle called a right-angled triangle. Is this a right-angled triangle? At this stage, you know that it is not. Why? Because it doesn't have an indication of a right angle triangle, or it doesn't show where the 90-degree angle is, and there is no statement that proves that it is a right angled triangle. I will therefore say it looks like it is a right angled triangle, but it is not. It can only be a right angled triangle if it has that. Now we agree it is a right angle triangle. The moment it has that, what we know is that one of the sides being the longest one, it is called hypotenuse. That's what we know. And then we will have two other sides. So which one is the hypotenuse? By now we know very well that it is a side facing the 90 degrees. So that means this is the side which is our hypotenuse. On the formula, we can still refer to that as R. So now we know we've got side 1 and side 2. Doesn't matter whether that other one you refer to it as side 1 and the other one side 2. Then we said the formula that we use in order to calculate the other sides, it is this one which says r squared is equals to, let me just say, side 1 squared, and you plus it with side 2 squared. It doesn't matter if you write it as r squared equals x squared, that you plus it with y squared. What matters the most is that you are saying the longest side is equals to the other side and that other side. Each side is being squared. So at this stage, this is what we know based on theorem of Pythagoras. So now we are going to build up from that knowledge and start talking about trigonometry. But before we can do much or say much, let me just quickly rewrite it there and say trigonometry. I might not need to write what I'm going to say, but I would like for you to listen very carefully. The word trigonometry is actually derived from two Greek words, being trigon. Let me just write it down because we are not necessarily in a hurry. Trigon, and again metron. And just do that and say metron. So okay, what does the Greek word trigon means? It actually means a triangle. That's what trigon means. It means a triangle. Okay, And then what about metron? It simply means measure, honorable member. So that means you can already see that we are talking about measuring, and then we're talking about a triangle. So in other words, trigonometry literally means measurement of a triangle. That's what you need to know, honorable member. We are just measuring a triangle, not just a triangle, but this specific one being a right-angled triangle. So that means you will always use your knowledge on trigonometry in order to answer questions related to a right-angled triangle. The only way we can measure a right-angled triangle, that's if we can have the ability to calculate the hypotenuse, to calculate side 1, side 2, and 3 angles. Already we know that this angle is 90 degrees. What about that angle, and what about that angle? The moment we are able to calculate the 3 sides and the 3 internal angles, that's when we have mastered this lesson for today, which is about measurement of a triangle. So I'm just going to make an assumption that you are completely clueless, and I will start you from scratch. Trust me when I say you will understand it's not necessarily a complicated thing to do. So now let me introduce you to a new knowledge regarding this type of a triangle. So what you should know is that we do have a right-angled triangle having 90-degree angle there. One thing for sure, we know that this side is hypotenuse. So let's work towards giving the other sides the names, so that we no longer say side 1 and side 2, but we give it a specific name. So we have 2 possible names that we can assign to those other sides. And since this one is called hypotenuse, the other side can be opposite, and the other side can be adjacent. So that means on this part of the lesson, I'm going to be teaching you on how to name the sides of a right-angled triangle. How are you going to know which side is which? You will only know based on the position of the inside angle. That angle can be theta, it can be beta, it can be alpha, or it can be angle A, or any angle between letter A up to Z. So to keep it simple and easier, let's choose theta as the angle that we are going to be using. So we have this side, which we used to call side 1, we have this side we used to call side 2. We no longer want to call it side 1 or side 2, but we want to call it opposite, or we want to call it adjacent. So the question now is, which side is it going to be adjacent, which side is it going to be opposite? You must always start by naming opposite, because once you know which side is opposite, the remaining side will be the obvious one being adjacent. How are you going to know if the side is opposite? You need to know where is this angle in that triangle. So that means if I put that angle theta there, which side is opposite that angle theta? Definitely it is this side. That's how you know that this is the opposite side, and then the remaining side will be adjacent. It is as easy as that. But look at this. It doesn't necessarily mean that the side will always remain as opposite. It will always depend on where the angle is. if the angle is there, then it means the side opposite that angle, it is the one which is called opposite. So that means this is now the opposite, and that becomes the adjacent side. It is as easy as that. Okay, so now let me do some more examples so that it will make some more sense. Let's say I have that, and then I have 90 degrees there, and then I'm going to put an angle, let's say there. Now let's name the sides. This side is hypotenuse, and this side, it is the one which is opposite because it is facing opposite that angle. Then the remaining side will be the obvious side, being the adjacent side. Okay, then it's fine. What if, or what about we have, let's say this, and 90 degrees there, I'll put an angle there, and then I will say this is the opposite, the hypotenuse, because it is facing opposite the 90 degrees. Which side is facing opposite the angle? It is this one, that it is the opposite side, and then that one, it is the adjacent side. So if you can know which side is hypotenuse and which side is opposite, then you are done, because hypotenuse is easy. Opposite, it will depend on where the angle is, and then the remaining side will be the adjacent side. So even if a triangle is like this, it doesn't matter the form or the shape. What you just need to know is that which side is the hypotenuse, definitely that one. Which side is the opposite? It is definitely that one, because it is opposite that angle. Therefore, this side, it is the adjacent side. So it should be as easy as that in terms of identifying which side is which. So now let's try to be more advanced and say, if you are given a right angle triangle like that, in most cases they can say that point is A, this point is B, this point is C. 90 degree there. So mathematically, when two letters of capital letters are combined together, they tell you the distance to say from A to B. It simply means this side name. And then if we say B, C, it's always small letter, or the letter that comes first and then the second one, just like A, B. A comes first, B comes second. So if we say BC, we are simply saying from B to C. So that means we are talking about that side. And then if we want to talk about this vertical side, we no longer say that side, but we say side AC. So that means when you name the sides, you can say, or the question can say, what is the name of side AB? Then side AB, we know that it is the side opposite that 90 degree. It is therefore our hypotenuse side. What about side AB? You can't tell what side AB is because you don't know or have the reference angle. You can only tell what side BC is or what side AC is if you have the reference angle. It is that one where I was saying, if we put our reference angle here, then we will know that this is the opposite side. But if things change and the reference angle is there, then the opposite side becomes this one. That's why I'm saying you can never tell which side is which until you have the reference angle. This side AP is easy because we just need to know where is the 90 degree. So if I put the angle there, then it means side BC, it is our opposite. And then the other side being AC, it is the obvious one being adjacent. So that's how it works in terms of naming the sides. And I wanted to spend enough time on this because that's where you will struggle the most. And the moment you struggle with this part, please make sure that you do not allow yourself to continue before you master it. Just make sure that you ask as many questions as you can until you are certain that you don't have problems with naming the sides, because all the questions will be based on you being able to name the sides. So for now, I'm just going to continue with an assumption that you are able to name the sides. So that means what I've just taught you, it was the naming of the sides of a right-angled triangle. So now what I'm going to explain, it is the trigonometric ratios. Let me just write it down there and say trigonometric ratios. I'm pretty much sure that by now you know what trigonometry means. It simply means the measure of a triangle, whereby for you to be able to measure a triangle, you need to know the names of the three sides, and you must also have the inside angles, the three inside angles. So what I'm now talking about, or what I'm going to be teaching you, is the trigonometric ratios. What is a ratio? The ratio simply means something over something. That's what a ratio means. So that means I'm going to be talking more about this over that. Since we are talking about a right-angled triangle, the only thing that we can talk about is taking a side and dividing it by another side. Taking a side, dividing it by another side. So since a triangle has three sides, we can therefore have three ratios that we can talk about. What are those ratios? We have the trigonometric ratios named sine, cosine, and tangent. Sine, a cosine, and lastly tangent. I'm going to take my time explaining this because it is the most important part of this topic. Sine, cosine, and tangent. So the ratio for sine, it is opposite side over hypotenuse side. I'm sure by now you know what the opposite side is, you know what the hypotenuse side is. And then with regards to the cosine, the cosine, we will just shorten it and say cos, just like with the sine I said sin or sine. So the ratio for cosine, it is actually adjacent side over hypotenuse side. And then for the tangent, then let's shorten it to say tan. It is the ratio of opposite over adjacent. I remember when I used to study on my own, having to figure out how am I going to remember this, especially if, let's say, you are seeing it for the first time. How am I going to remember that there's something called sine, cos, tan, and the ratio of this is this, and the ratio of that is that, and all of that. Because for you to continue and successfully answer the exercises that you might come across, you will definitely need this knowledge or this understanding of the sine, cos, and tan, and knowing their ratios. So now this is the best way to go about it. I'm pretty much sure that your teacher is still going to teach you this. I'm curious to know if I should write it up there, or maybe let me just be fair and continue here, just so that I don't have scattered information. So you see, I've spoken about the sine, the cos, and the tangent. Let's try to shorten it and say, what if we want to know that sine is the ratio of opposite over hypotenuse? Let's take the first letter of sine, which is S. Nay. The first letter of opposite, which is O. The first letter of H being hypotenuse. Then we have that. Let's jump onto this one, and we take that, and that. So that means we have C for cos, A for adjacent, H for that hypotenuse. Let's jump onto tan. We will say T, O, A. Okay, so that means now we are taking a T for tan, O for opposite, and then A for adjacent. Okay, so we have taken that, and that. And when you look at this, if you try to make sense of this or read it as one word, it looks like it's SOHCAHTOA. SOHCAHTOA. So the main aim was to try and simplify this thing of sine being opposite over hypotenuse, cos being adjacent over hypotenuse, tan being opposite over adjacent. Now we have shortened it to make it SOHCAHTOA. So going forward, I will only talk about SOHCAHTOA because it's a short version of what I've already explained. So that means the S stands for the sine, which means sine is the ratio of O over H. O opposite, H hypotenuse. And then C, it is the ratio of A adjacent over H for hypotenuse. And then T, it is equals to the ratio of O for opposite over A for adjacent. Trust me when I say, if you can master this knowledge, you are definitely going very far. Definitely going very far. So now let me continue with today's lesson and teach you this, which is connected to what I have already explained. So let us say for some reason you are having that as a right angled triangle. This should be that, and then there we are having 90 degrees there. So something that you should be aware of is that based on what I have explained, we will use that information in order to calculate the angles. So you may, for example, be given, let's say this side being 2, and then this side, let's say, being 3. Trust me when I say, since triangle, it's a shape of 3 sides and 3 angles. All that you will always need is 2 known things or 2 known values. For you to be able to calculate everything regarding that right-angled triangle. When I say 2 known values, can you see? I'm given a right-angled triangle there. and the values that I'm given is just 2 and 3. So what I'm saying is, this is enough for you to be able to calculate everything about that right-angled triangle. I'm going to prove it to you just now. So this is how it works. You need to know which side is which. Definitely, we know this side is hypotenuse. Based on that angle being there, then it means this side is opposite. And then this is the obvious side being adjacent. So, trigonometry being a measure of a triangle, so that means we must know what the hypotenuse side is, we must know what that angle is and that other angle if we need to calculate it. But always, if you have two sides and you want to know what that side is, you can still use theorem of Pythagoras. Only when you need to know what the angle is, then you will rely on the sine, the cos, and the tan ratios. And this is how it works. So you remember you have, maybe let me start the same way I've started regarding SOHCAHTOA and say, you will say sine of an angle is equals to, what did we say sine is? Opposite side over hypotenuse side. And then when it comes to cos, that means cos of any angle of a triangle equals to adjacent over hypotenuse. And then when it comes to tan, we said tan of an angle equals opposite over adjacent. So when you are given a right angle triangle and they want you to find the side, you just need to know, am I going to use sine, am I going to use cos, or am I going to use tan? How are you going to know? It will depend on what you are given. So I just said I am given opposite, which is 2. I am given adjacent, which is 3. So between sine, cos, and tan, which trigonometric ratio has opposite and adjacent? Is it sine? No, it's not, because for sine is opposite and hypotenuse. Is it cos? No, it's not cos, because cos has adjacent and hypotenuse. It just has to be tan if it's none of those, because tan has opposite and adjacent. So that means the correct trigonometric ratio to use to calculate the angle, it is tan. Then you will say tan of an angle is equals to, the formula says opposite over adjacent. Then what you do is just to substitute. We will say tan of an angle equals, what is opposite? Opposite is 2. What is adjacent? Adjacent is 3. And then the last step, you just need to remove that tan. So you can't divide by tan, but you just say second function of tan, and then you multiply it by 2 over 3. This is where you would write your final answer, but because I don't have space, maybe let me write it there. So how do you do it? Sometimes they say arctan, arccos, or arcsine. On your calculator, you click on shift, then you click on tan. You will see that it will it will do this thing of tan to the exponent of -1. It's because it is actually pressing that letter that is written or the text or the paint above that button. That's what the shift does. And then you punch 2 over 3. And then you close the bracket, and then the answer that you get is 33,690. If we round it off to 2 decimal places, then we will leave it there, but remember to say degrees because it is an angle. If you don't write degrees, it's wrong. We are not sure if you are 33 years, 69 maybe months or days old. So you must write degrees there so that I know that you are calculating an angle. So that is how you would calculate an angle. So maybe let's try another example. Maybe this time around, let's say this is what we have, and then there's the 90 degrees. Let's say maybe this side is 4, then that side is 2. I'll put an angle there and say beta. Okay, again, very, very much important. The first thing that you need to do is to name all the sides. Obviously, this side, it is hypotenuse. And then, which side is the opposite? This side, it is the opposite. And then this is the one which is the adjacent. Remember, I said you just need 2 known things. And you can be able to calculate anything. So what I'm teaching you now, it is to calculate the angle. Because you already know from previous lessons how to calculate the sides where you use theorem of Pythagoras. So now let's see, how are you going to work it out? The first step is that one of identifying the sides. The next step, you ask yourself a question to say what are you given, so that you will know whether you need to use sine, cos or tan. Let's see. What are you given? You are given opposite and hypotenuse. Which trigonometric ratio has opposite and hypotenuse? Could it be sine? Let's see. Oh, yes. Sine is the ratio of opposite and hypotenuse. So that means with you having to work it out, you will therefore easily say sine of an angle, in this case the angle is angle beta, it is equals to you firstly write the formula and say opposite over hypotenuse. Then let's see, you will say sine of that angle is equals to what is opposite? Opposite is 2 over what is hypotenuse? Hypotenuse is 4. Then the next step is for you to remove that sine. How do you remove it? You will therefore say nope, not that. I'm still thinking about the previous one, but now you will say arc sine of 2 over 4. Then you punch it on your calculator, you click on shift, and then you say sine, and then you say 2 over 4. Something very much important, make sure that your calculator, in terms of the mode, it is in degrees. If it is not in degrees, then you will not get these values that I'm getting. So it's a setting that you need to make sure. It's like if you are driving an automatic car, if you want to go forward, make sure that the gear is on D for drive. But if for some reason it's on R, then it will drive in reverse. So that's why I'm saying, when you are dealing with trigonometry, always look at the screen of your calculator, check somewhere you should see D. If you see D, it means it is in degrees and you are safe. But if it's R, I think the other one is G, maybe for grade, yeah, something like that, then you will not get the correct answers when you punch shift and then sine, or shift cos, or shift tan. So just make sure that if your calculator there, it's not D, then you need to set the mode. Let me quickly check. The mode, you click on mode. Okay, maybe let me just leave it for now. In case if you don't know how to, I will explain to you how to do it, just so that I also don't mix it with the lesson and it ends up confusing you. But just make sure that it's in degrees. If it's not in degrees, it's fine for now. Just follow what I'm doing. I will calculate, and then you will sort it out and redo all this that I am doing. Okay, then it's fine. So now let's say we have that. Maybe let's put the angle 90 degrees there, and then from there, it's fine. We can maybe put angle A there, and then what else? Let's say we have this side being 3, and then maybe that one being 5. Yes, that one being 5. And now the question is, what is the value of that angle A? Again, you need to identify all your sides. Which side is which? Definitely this one is hypotenuse. And then this side definitely is adjacent. And then that other side is opposite. You just need to know two things. Of course, I do have my adjacent there. Of course, I do have my hypotenuse there. So which trigonometric ratio has the not the opposite, but the adjacent and the hypotenuse? Could it be sine? Nope, it's not sine, because sine talks about hypotenuse and opposite. Could it be cos? Oh yes, it seems to be cos, because it is the one that has the adjacent and the hypotenuse. Easy. You will say cos of what angle are you given? Are you given alpha? Are you given beta? Are you given something else? It is something else. So you write it as it is. Then cos of that angle is equals to, what is it? It is therefore going to be adjacent over hypotenuse. What is the value of A? The value of A is 3. What is the value of H? The value of H is 5. And remember, what you are calculating is cos of that. Okay, so now let's see. That angle A will therefore be equals to cos of that. Remember, it is the cos of that, or shift cos. Then let's punch it on our calculator. I will say shift, press on cos, and then it will be fraction of 3 over 5, which is equals to 53,130. I need to say degrees because it is an angle that I am calculating. Then it means you are done. So remember, there is no way you can move on to some more complicated problems for trigonometry without you being able to understand all of this. The only way you can verify if you understood, that's if you go through a test. And in all the tests that I'm giving you, I want to make sure that all your final answers are correct. I'm not necessarily testing you on the steps in between, because I want to make sure that when you get to the workplace and you have a client and they say, do I turn right or do I turn left? You don't have to explain to say, okay, you need to consider this and all of that, comrade, we need to deal decisively with it in this way and all of. Nope. No. As your client, I want to know, do I turn right or do I turn left? That is the final answer that I am expecting from you, so that when you say left, it's either is wrong or it's right. If you can be able to tell the truth and say turn right and is correct, it means everything in between is correct. And also, it definitely means that you understood. And without the guesswork. So that's why you will need to work it out and see if you get the final answer wrong or correct. Okay, so then it's fine. So now let's continue. And I want to expose you to different ways in which questions may be asked. Okay, so now let's see. You can be given something which is like that, and then that being 90 degrees there. And then let's say you are given angle theta there. After you are given that angle theta there, what else? Let us say you are given that point, they call it A, B, and then C. And then let's say they give you this side and they say it's 2, and then this side they say it is 4. If a question is considered to be tricky, that's, for example, if they say calculate angle A. Can you see? It definitely looks a bit complicated because they are talking about angle A. How are you going to get to angle A? How are you going to get to angle A? You cannot be able to get to angle A before you calculate angle theta. So that means you need to somehow get to angle theta so that you can therefore be able to get to angle A. Maybe let us see how we can work it out. By now, I can see that I have opposite, I have adjacent. The trigonometric ratio to use is definitely going to be tan. Then I'll say tan of an angle will be equals to opposite over adjacent. So tan of an angle is equals to opposite being 2 over adjacent being 4. So now it means the angle, it is going to be that of 2 over 4. Therefore, the angle will be shift tan 2 over 4. You close that, it's equals to, this is now 26,57 degrees. If I round it off to 2 decimal places. Okay, then it's fine. It means I know what that angle is. So let me show you something that they taught you in your lower grades. They said if you have a right angle triangle, I'm just redrawing that one of a point A, B, and C having that, and then there being 4, that being 2. I just calculated this angle and is 26,57 degrees. What did they teach you? They said the inside angles of a triangle add up to 180 degrees. Interior angles of a triangle add up to 180 degrees. So I'm going to use that same knowledge to get to angle A. So that means when I take angle A, being that one, and I plus it with that angle at C or angle at B, doesn't matter, and I plus it with that angle at C, they must add up to 180 degrees. Angle A is what I'm looking for. What is angle B? I just calculated it now, is 26,50 or 57 degrees. What is angle C? That one is always 90 degrees. And then we have 180 degrees. So can you see? Now all that you need to do is like you're solving for x, but you're solving for a. So you just see 180 degrees minus 90 degrees plus 27.57, and then it gives you 63,43. Remember to say degrees because this is an angle. That's all that you need to be aware of, honorable member. So can you now see I've just calculated that, which is now 63,43 degrees. Guess what? I've just calculated the two angles. I have almost everything about that right angle triangle. The only thing which is missing is the value of the hypotenuse. So that means the question now is, how are you going to know that side AB being the hypotenuse? Easy. I will use theorem of Pythagoras, which says that hypotenuse squared, I will just take the opposite side I squared, I take the adjacent side I squared. So that means the hypotenuse squared will be equals to my opposite side when you use theorem of Pythagoras, it doesn't matter which side is opposite, which side is adjacent, just like you've noticed in the past lessons. So definitely we have 2 squared plus 4 squared, which is equals to 20. Then you will need to square root both sides, so that means h is equals to square root of 20, and then it gives you 4,47. So that should be the end of it. The only thing which will prove that you've done it correctly, that's if the value of h, or your hypotenuse h, is the longest side, because if this side is 4 and that side is 2, then this side, it has to be longer than 4. That's why it is that 4,47. But if it was smaller, then you know something went wrong, because the hypotenuse is always the longest side. I'm hoping that all that I've explained up to this point makes sense. So maybe very quickly, let me show you to say, if you are given something of this nature, and then you have that, let's say they give you 30 here, doesn't really matter that much. And then let's say nope, not 30 degrees. What am I doing now? 30, let's say 30 meters, it's fine. And then even here, if they give you, let's say 20 meters, and if they put an angle there, what you should know is that you can be able to calculate the other unknowns. And the other unknowns, it is this side and it is also that angle. So if you have 2 sides, you want the other sides, you can always use theorem of Pythagoras. Nay. But if it involves the angles, then remember the cos, the tan, or the sine. So according to me, this side, it is the adjacent side, and this side, it is the opposite side. So use cos to calculate that angle. Once you know what that angle is, use that understanding which says the sum of inside angles of a triangle add up to 180 degrees. Then from there, you will therefore be able to know what that angle is. Once you know what that angle is, then you can therefore use theorem of Pythagoras to know what is that side. That's it, honorable member. So the main aim, it is mainly for you to be able to, it's for you to be able to know which side is which, where to start if you want to calculate an angle, and all of that. So maybe as I wrap up, very big notes. In case of for some reason you need to refer to these notes, I think for now you can take a screenshot. Otherwise, if you don't need to take a screenshot, you can just drop me WhatsApp a text to request for these notes, and then I will check if there's a way in which I can make them available on the website. Just so that as you practice, you redo exactly what I've done, and also you redo what I've done before you start doing some exercises, because I'm going to test you based on what I am teaching now. So let me just quickly check on my notes in terms of whether I've explained everything. So some of the questions that I'm going to ask you is, let's see, redraw the triangles below and indicate which side are opposite, adjacent, and that. Okay, so the questions that you might expect is where I expect you to redraw and then name the sides to tell which side is which. And then the other type of a question, that's where I would say state the following in terms of G, K, and M. What an interesting one. Let me just take my time to introduce you to this type of questioning. where they say this point is K, let's say that one is M, and then this one is G. Okay, so now let's say we give you this as M, and then we give you this as K, and then we give you this as G. What an interesting question. So if I say to you, state the following in terms of G, K, and M, and then number one, I say sine K. So what I want you to do here, it's like I want you to therefore assume that K is the reference angle. So that means this is now the reference angle. What we know is that sine K or sine is opposite over hypotenuse. But you need to rewrite it in terms of M, G, and K. So which side is opposite? Definitely it is that a small letter K. Which side is hypotenuse? Definitely is that small letter M, because it is the side opposite that 90 degree. So this is now what I want in terms of your final answer. So that means the final answer that I am looking for is this one, where you say sine of angle K. It's actually K over M. That's it. So maybe let me quickly give you another one. Let's say I'm giving you a triangle there, and I say this is A, this is B, and then this is C, and then I will say this is small letter B, small letter A, small letter C. Be careful of that. And then I say state the following in terms of A, B, C. So that means when I say state the following in terms of A, B, C, the final answer that I'm expecting from you, it's you saying A over B, or C over A, or maybe A over C, whatever the case may be. So the moment I say number one, state tan C in terms of A, B, and C. It's like I'm saying take C as the reference angle. Then with a pencil, you can just do that. Then now we know what the reference angle is. Then you can just say tan, what I know is opposite over adjacent. My battery is low. Okay, let me resume. Tan angle C is equals to opposite over adjacent. So when I look at this right angled triangle, which side is opposite and which side is adjacent with reference to that angle C? Opposite definitely is going to be C, and then adjacent is that side of small letter A. That's it. This is the final answer that you are expecting to get. It doesn't end there. Another question, due to space, I will write it then. Say another question, they can still say sine of A. So if they say sine of A, then now it means you need to erase with your pencil, you need to erase that part which was your reference angle, because for sine A, now the reference angle is at A. Now if the reference angle is at A, things change. But what we know is that the ratio for sine is opposite over hypotenuse. If the reference angle is at A, then which side is opposite? Definitely the opposite side is A. And then which side is the hypotenuse? The hypotenuse definitely is B. So that means all that I'll be looking for is A over B. That's it. You can only be able to do this if you are able to know or if you are able to name the sides. Very, very much important, honorable member, on that one. Okay, so another way in which I'm going to ask you the questions is this way. Let's see. Looks like I no longer have space. Let me just add a blank page there. Let me just add a blank page just so that I'm being fair on myself. Okay, then it's fine. So another way in which I'm going to ask you some questions is, for example, where I can give you, let's say I give you a right angle triangle. Let me say maybe this is Q and then this is P. Maybe that point is R. The side facing opposite that Q, let's make it small letter Q. Then that should be R. So that this is small r and that should be small p. Okay, for example, I would say state the following in terms of P, Q, and R. But also, after I've given you that being the angle and I've given you that being the angle. Okay, after giving you that, then the next thing that I would ask you is to say, maybe as number one, I can just say, state the following in terms of P, Q, and R if you are having sine of an angle. Yeah. So if you are having sine of an angle, what we know is that sine is the ratio of opposite over hypotenuse. So if this is the reference angle, automatically R is our opposite, and then Q, it is our adjacent. Then you are done. But for some reason, if a next question comes, and then as it comes, they no longer reference to that angle theta, but let's see the next question as an example. It says tan, let's say tan theta. So that means in this case, the reference angle is that one. What we know is that tan is opposite over adjacent. Then if the reference is this one, which side is opposite that? Definitely it's P. What about the side which is adjacent to that? It is definitely R. So that's how tricky things can be. But trust me when I say they will only start making sense if you do them over and over and over again. Because what I'm testing you on, it is an understanding to make sure that before you can continue, you fully understand these basics. Because once you understand these basics, trust me when I say you will never go wrong. So other questions that you may be asked on, trust me, those are going to be easier questions where I'm actually, in short, asking you in terms of which side is which. Maybe I'm giving you a right angle triangle. Maybe I can say that this side is 24 centimeters. Maybe this one is 14 centimeters. Then I'm just asking you in terms of what that side is. By now you should know where to start in calculating the side, and maybe I can say to you, right, maybe the values of whatever the case may be. It could be the value of this, the value of that, the value of that. It wouldn't be a complicated thing that you might need to do. You might need to trust me on that one. Okay. Then it's fine. What else? I think I've actually covered all that I wanted to make you aware of. I think for now I will just leave it here. But otherwise, in case if you are having any questions regarding what I've explained, just make sure to make me aware so that I can clarify.